Okay, I want to talk briefly about the zeroth law of thermodynamics. Historically, it was something that was kind of forgotten about until after the first, second, and third law were written, but it turns out it's pretty important. As you can see, it establishes temperature as the fundamental property of matter that is measurable. I think I forgot an A in there, temperature. Sorry about that. Anyways, here it is in a nutshell. If A is in thermal equilibrium with B and B is in thermal equilibrium with C, shocking! They're in thermal equilibrium with each other, A and C. So while this seems pretty ridiculous, it seems quite obvious. Maybe you could see why it was perhaps overlooked. Let me try to give you a visual example of why this is actually worth mentioning, and then we'll move on. All right, so here is a thermometer in Celsius, and you can just barely see we're at 20 C. I know the markings are hard, but there's a faint red line in there that's at 20 C. And so right now, you could think of the water as material B and the thermometer as A. So the thermometer is in thermal equilibrium with the water. And then what I'm going to do is get a third object here. I'm going to heat it up for a little bit, not too long. Whoa, I guess I'm going to set off the fire alarm too a little bit. Hopefully not. Toxic fumes. Why do chemists get cancer more than anybody else? I don't know. Okay, so let's say this is heated up a little bit, and I'm going to put that in. And now the thermometer is probably changing a little bit. I'm going to try to watch on screen here. I don't know if you can see it changing at all. Not much. But the idea is, this gives you a visual. You could imagine, I don't know what temperature that piece of metal is at. If I had heated it up longer, maybe it'd be at a different temperature. But in the end, when the water and the thermometer reach thermal equilibrium again, I'd be like, oh, that must also be the temperature of this piece of metal in here. So that's why we're always using an ice water bath in chemistry, because you know the ice and the water in thermal equilibrium at 0 C, so anything else you put in there must also be at 0 C. Similarly, boiling water is at 100 C, so we know assuming we're at standard atmospheric pressure. If we put something in a boiling hot water bath, you know that object that you put in there is also at 100 C. That's the main reason we're going to use this. Let's leave it at that. Did it go up at all? No, it didn't, but the room sure stinks. That's great.